All right, let's get right into it. Picture this, a factory floor. It's humming with activity, right? But here's the twist. The lights are completely out. No people anywhere. Just machines, building things with absolute precision, all in the dark.
And no, this isn't some scene from a sci-fi movie. This is a real quote, a real rule from an actual software project. And it points to something huge, a revolution in how we make, well, everything. Because we're talking about the software that makes everything run.
So what we're talking about here is the dark factory. You know, this idea has actually been around for years in manufacturing. You've got these factories where robots are assembling cars or whatever, 24/7, no lights needed. But the really wild part? That same lights-out revolution is jumping from the assembly line right into the world of software, into the code base itself.
So, how in the world did we get here? To really get it, we need to trace the path, from a human tapping away at a keyboard to full-blown autonomy. Because this kind of thing, it definitely doesn't happen overnight. Okay, so this whole journey to a software dark factory, it basically happens in 5 steps. It all starts out pretty simple, with AI as just a helpful assistant. Think GitHub, Copilot, that kind of thing, which a ton of developers are already using. But as you move up the ladder, the whole relationship just flips. By the time you hit level 5, the true dark factory, it's a whole new ballgame. You just feed it a super detailed spec, and out pops working software. No joke. But here's where it gets really weird. You'd think giving these powerful AI tools to skilled, expert developers would make them faster, right? Well, nope. A serious study actually found their productivity dropped. They were 19% slower. I know, that sounds totally backwards. But stick with me, because we're going to circle back to exactly why that happens. And believe it or not, it's a super important part of the story.
So that begs the question, right? How is it even possible to build huge, complicated software with a tiny team where nobody is even writing or reviewing the code? The secret isn't just about having a smarter AI. It's about a completely different way of building, a whole new architecture from the ground up.
Okay, let's look at a real-world example to make this concrete. There's this company, StrongDM. Get this, a team of just 3 people. 3 are building this incredibly complex piece of tech infrastructure. And they're doing it with no sprints, no stand-ups, no Jira. Their whole operation is built on 2 simple but radical rules. Humans don't write the code, and humans don't review the code. Period. And this just perfectly shows you how the economics get completely flipped on their head. Normally in software, the most expensive thing by far is people's time. But in this model, it's compute power. StrongDM actually has a benchmark for this. They say if you haven't burned through at least $1,000 a day on AI compute, your factory isn't running at full speed. Think about that. It totally inverts the entire cost equation we're all used to.
So the first big piece of this new architecture is the specification, the spec. And we're not talking about your typical vague project document that people have to guess at. No, this is something called a natural language specification, or NL spec. It has to be written in plain English, but with such insane precision that there's zero room for misinterpretation. It's basically the direct instruction manual for the AI. In this world, if your spec is even a little bit fuzzy, that's not a suggestion, it's a bug.
Okay, so you're probably wondering, if no human is reviewing the code, how do you make sure it's any good? It's a great question, because if you just tell an AI to write the code and the tests to check that code, well, it could cheat. It's like a student writing their own exam and then grading it. They could just write a test that's super easy to pass. The clever solution here is something called a holdout set. Basically, the real tests are kept secret from the AI. They're hidden. So the AI has no choice but to build the code the right way, because it has no idea how it's going to be judged. It can't game a system it can't see.
And this one little trick completely changes the game for quality assurance. We're not measuring things like code coverage anymore. The new metric is something like an intent satisfaction score. Did the software do what we intended for it to do? And here's the kicker. When something breaks, you don't go digging through lines of code to find the bug. Nope. The problem must be in the original instructions, so you go back and fix the specification.
All right, the last piece of the puzzle is where the AI actually does its work. It operates in what's called a digital twin universe. Just think of it as the ultimate playground or sandbox. It's a perfect, high-fidelity virtual copy of everything the real software would need to interact with, services like Slack or Jira or Okta. This means the AI can build and test its creations in a super realistic but totally safe environment without any risk of messing up a live system. Okay, so this all leads to the big, looming question, the one everyone's thinking about. If the machines are writing all the code, what happens to the people? What does a software engineer even do in this new world?
Well, the roles are definitely changing, and fast. Research from Gartner is suggesting that a huge number, we're talking 80% of engineers, will need to seriously upskill by 2027 just to stay relevant. That's not that far away.
And this is really the heart of it. The big shift is to something called intent thinking. The most valuable person in the room is no longer the developer who can write the most elegant or clever code. It's the person who can perfectly and precisely define what needs to be built. They become the architects of intent. Their job is to think through every single possible edge case, every trade-off, and create a flawless blueprint for the AI factory to execute.
And hey, remember that weird productivity dip we talked about earlier, the negative 19%? This explains it perfectly. It's what's known as the J-curve. That initial drop is the price you pay for unlearning all your old habits, like the impulse to just jump in and start coding. It's the cost of learning how to do this really deep, hard work of intent thinking. But here's the cool part. Once you push through that dip, your productivity doesn't just come back to normal. It absolutely skyrockets.
Okay, so let's zoom out a bit. What does all this mean for business strategy? Because make no mistake, this isn't just a new tool for the engineering department. This changes the entire competitive landscape.
The companies that are already working this way, they're reporting absolutely mind-blowing results. Just using AI to help you code gives you a nice little boost, maybe 1.3x. But a true dark factory model, we're talking productivity gains of 3 to 5 times the old way. And some of the real pioneers are even claiming they're moving 10 times faster. That's just incredible.
And this is way more than just being faster. It literally rewrites the rulebook of business competition. Think about it. All those old, clunky IT systems that were too expensive to upgrade, suddenly that's doable. The whole build versus buy debate for software, it gets turned on its head when building custom software is actually cheaper. And imagine this. What happens when your competitor can dream up and ship a new feature in a few days when it used to take your team a whole quarter? The entire market has no choice but to speed up.
So what this all means is that human creativity is shifting. It's moving away from the keyboard and onto the drawing board. We're finally being freed from the nitty-gritty of how to build something so we can focus all our energy on the what and the why. Which leaves us with a really powerful and kind of exciting question to chew on. If software can build itself, what are we going to ask it to build next?